In this video, we're going to talk about probability trees, and we're going to do this by playing a game. So here's how the game works. You have 5 cards. 2 of them are aces, and 3 of them are kings. It doesn't matter what suit they are, as long as you have 2 aces and 3 kings in your set. So if you have a deck of cards at home, I recommend that you get it out and play this yourself. What you're going to do with your 5 cards is you're going to put them upside down and mix them up so that you don't know which is which. And then you're going to randomly choose a card. You're going to record whether it's a king or an ace. You're not going to put that card back in the deck, and then you're going to choose a second card. So when you choose your second card, there should be 4 cards to choose from. For your second card, you're also going to record whether it's an ace or a king. It's considered a win if both cards are aces or both cards are kings. If you get one of each, then it's not a win. It would be a loss. And we're going to play the game 10 times. So if you have cards at home, you can go through this yourself. I'm also going to put this Excel spreadsheet that I made to go through the game in Blackboard. So you can use this as well. It's probably easier if you use actual cards, but this works too. So here I have my 2 aces and I have my 3 kings. So this is my set of cards. What you're going to do is you're going to click on cell A4, and then you're going to see here the formula bar. You're going to put your cursor in the formula bar and click enter, and that's going to randomly choose a card. So I got the king of clubs. Then what you're going to do is go to the second worksheet of the Excel spreadsheet. And here I see my same 5 cards. What I need to do is remove the card that I got on the first draw from the deck. And I want to put the remaining cards in columns A through D of my spreadsheet. So I'm going to move the king of clubs, which is what I got in the first draw. I'm going to use cut and paste to do this on my keyboard. So I move the king of clubs out to column F, and then I'm going to move the king of hearts over into that space in column C, so that my 4 cards that I'm drawing from are in columns A through D. And then I go down here to cell A6 and click in it, and then I'm going to go again up to my formula bar and click enter, and that's going to draw a second card. So my second card was the king of hearts. So I got 2 kings. I won on my first time through. So I'm going to record my results here. So I got king and king, and then yes, I was a winner. So now I'm going to go through, I've already played this, and put my results here into this table, just to make this go a little bit faster. So on my second time through, I got king and ace, so I didn't win. My third time, I got ace and ace, so I did win. My fourth time was king and ace again, so that is not a win. And my fifth was ace and ace again, so that's a yes. And then I got king and ace again, so that's a no. On my 6th time, my 7th was ace king, and so that's a no. And then I got ace king again, so that would be a no. On number 9, I got king and king, so that's a yes. And I got king and ace on number 10, so that one was not a win. So what we want to do is calculate, based on these results, the probability of winning the game. So remember, this is an empirical probability because it's based on the result of an experiment. What we were just doing was an experiment. And so our probability is going to be an empirical probability. So looking at my results here, I have 4 wins, 4 yeses, out of 10 total times playing the game. So my probability of winning is 4/10. So now we're going to use a tree diagram to calculate the theoretical probability. So 4/10 is my empirical probability. I could continue playing the game more times to get a more accurate empirical probability, but the theoretical probability we're going to calculate here using math. So I'm going to start by figuring out what is the probability that I get an ace from my first draw. And so based on my set of cards that I'm starting with, I have 2 aces and 3 kings in the set. So that means my probability of getting an ace is 2/5. And then my probability of getting a king on the first draw would be 3/5 because there are 3 kings out of 5 total cards. Now, when figuring out what my probabilities are for the second round, remember that the first card is removed from the deck and I don't have it in there anymore. So for example, when I played, I removed this king, and so in my deck I had 2 aces and 2 kings left. So if my first card is an ace and then I remove that ace, what's left in my deck is 1 ace and 3 kings. So the probability of getting an ace on the second draw is going to be 1/4 because there's 1 ace out of 4 total cards. And then my probability of getting a king would be 3/4 because there are 3 kings left in the deck out of 4 total cards. If I remove a king on the first draw, then I have 2 of each left. So my probability of getting an ace on the second draw is 2/4, and my probability of getting a king on the second draw is also 2/4. Now, to find the probability, I'm going to multiply the probabilities of each. So it's the probability of getting an ace on the first draw times the probability of getting an ace on the second draw. Since this is an and situation, I am multiplying the probabilities here. So that's going to be 2/5 times 1/4. I'm going to make this box bigger so that you can see it. And remember that when you're multiplying fractions, you're going to multiply the numerator and multiply the denominator. So my numerator is going to be 2 times 1, which is 2. And my denominator is 5 times 4, which is 20. So I get 2/20, which I can simplify to 1/10. These are nice numbers, so I could be using decimals here, but when you're doing this on the homework, you're going to have not such nice numbers, and they're going to ask you for fractions. So that's why I wanted to practice using fractions and fraction multiplication here. So the probability that my first card is an ace and my second card is a king is going to be 2/5 times 3/4. And then when I multiply those together, 2 times 3 is 6, and 5 times 4 is 20. So 6/20, which I can simplify to 3/10. Probability that the first card is a king and the second card is an ace is 3/5 times 2/4. And when I multiply those together, I get 3 times 2, which is 6 for my numerator, 5 times 4, which is 20 for my denominator, so that's also 3/10. And finally, the probability that my first card is a king and my second card is a king. That's going to be 3/5 times 2/4. Again, that's going to be 6/20, or 3/10. So question 3 says to find the theoretical probability of winning the game. So I win the game, remember, if I get both cards the same. So I can win if I get 2 aces, or I can win if I get 2 kings. If I can get my highlighter to work here. So to find the total probability of winning the game, I would add these two probabilities together. So the probability of getting both aces is 1/10, and the probability of getting both kings is 3/10. So my total probability of winning is 4/10. And so actually I was pretty good with my empirical probability here. I got the same as the theoretical probability, and that just happened to work out. If you played it yourself, you might have got a slightly different value for your empirical probability, and that's totally fine too. So my theoretical probability of winning is 4/10. And the final question here says, what is the probability that the first card was a king, given that the person won the game? So here we have our word given, which should be a clue to us that we're talking about a conditional probability. So, the probability that the person won the game is 4/10. I'm going to switch that to a decimal here. And then the probability that the first card is a king and you won the game is 3/10. Oops. So the probability the first card was a king given you won the game is going to be 3/10 divided by 4/10. So in this case, the 4/10 is the total, because that's going to be the part that's given, and then the probability that you're looking for is the probability that it was a king. So the probability that it was a king was the 3/10. So 3/10 divided by 4/10, and if you divide that, you get 0.75 or 3/4. So given the person won the game, there's a 3/4 chance that they won with both kings and only a 1/4 chance that they won with both aces.